Now let's take a look at small changes. We have been doing a lot on partial differentiation, and the last part we'll be considering as regarding that aspect is small changes. Now, if z is given as a function of 3 variables and the small changes are given as delta u, delta v, and delta w, then the small change in z is given by, is approximately partial derivative of z with respect to u multiplied by the small change in u plus partial derivative of z with respect to v multiplied by the small change in v plus partial derivative with respect to w multiplied by the small change in w. And now we have an example to establish understanding in that case. Now we are given that pressure P is and volume V of a gas are connected by the equation of PV raised to power 1.4 is equals to K. Determine the approximate percentage error when the pressure is increased by 4% and the volume is decreased by 1.5%. Now, we are dealing with K here. So we can say that K is a function of P and V. Therefore, the small change in K is approximately partial differentiation of Z, of K rather, with respect to P multiplied by the small change in P plus partial differentiation of K with respect to V multiplied by the small change in V. So now let us evaluate the K dP and the K dV. Now, since we are given that this is PV raised to power 1.4 and we are differentiating partially with respect to P, therefore V is a constant and we differentiate fully with respect to P, and this will give us V raised to power 1.4 multiplied by 1. That's V raised to power 1.4. And for the K dV, PV raised to power 1.4, and in this case the P is considered as constant and we differentiate fully V raised to power 1.4, and this will give us P into 1.4 V raised to power 0.4, and this will be 1.4 P multiplied by V raised to power 0.4. Now let us consider the small changes in pressure and the small change in volume. Delta P and delta V. Now, if we look at the question again, it says that determine the approximate percentage error when the pressure is increased by 4%. Now, since the pressure is increased by 4%, the change in pressure, delta P, is equal to 4 over 100 multiplied by P, and this will give us 0.04 P. And the volume is decreased by 1.5%. And now, since the volume is decreased by 1.5%, the change in volume is minus 1.5. It's negative because of the reduction over 100 times V. and this will give us minus 0.015 V. Now, let's now go back to our formula of small change in K and make substitutions. So small change in K is approximately delta K divided by delta P. Sorry, small change in K is dk dp, that is V raised to power 1.4 multiplied by change in P, which is 0.04 P, plus dk dV, that is 1.4 P V raised to power 0.4 multiplied by the small change in V, and that is minus 0.015 V. Now with this done, we can now simplify further, and this will give us 0.04 PV raised to power 1.4, and this should give 1.4 multiplied by 0.005 0.015, and that will be 0.021 PV raised to power 1.4. Therefore, we can now factorize with PV raised to power 1.4. I think we made a mistake. 1.4 multiplied by 0.015. No, 1.5 divided by. Let us factorize therefore with PV raised to power 1.4, and then we have 0.04 minus 0.021, and this will give us PV raised to power 1.4 into 0.019. Now, taking a look at this now, we know that PV raised to power 1.4 from the question is equal to K. So this is equal to K, and 0.019 is the same thing as 1.9 divided by 100. So we can see that this one is positive. Therefore, the approximate error in K is a 1.9% increase. Now, it's very simple. The first thing to evaluate is dk dp and dk dv, and just like we have been doing, just like we did for rate of change, and we got change in P and change in V, we substituted and then we factorize, and we have our final answer.